Well, hi and welcome to my shop, and thanks so much for joining me here. And we're just going to start work on this Crosley radio just before I get started. Since this may be the first time you've watched one of my videos, my practice is to basically work on the radio, video running, and whatever happens, happens. That's pretty much it. I don't edit my videos very much. Often things go very nicely, sometimes things go really crazy. So there you are. So watch, and also I make mistakes in here, and I say things that aren't actually true. Sometimes what's in my head is correct, and what comes out of my mouth is not. I don't even realize it. So just beware. You need to have your thinking cap on a little bit while you're watching my videos. So here we go. So the condition of this radio is I don't know. The word is it works. I can see already it's got a cord attached by somebody else. It's got a replaced cord, so that suggests somebody's been in here working on it. And also, this nice white radio obviously was a black radio when it was born, and the white paint, which is a nice paint job on it actually, has been chipped off all over the place here. Just something to note about these radios, and I guess everything in general. Look where the damage is on the radio. It's in this area and in this area. It's the same area on either side. And most of these radios, wooden ones in particular, you'll notice that the damage that occurs to them is typically on corners like this and other protrusions that occur, like maybe on these or things like that. And often the main body of the radio, including this one, is actually in really good shape. This one doesn't really have trim, it just has a complicated shape to it. But in other radios, the solution is to just paint the trim a little bit, and you can make 90% of these things disappear just with a little bit of paint. And it's not obvious when you first look at the radio, especially a wooden one. Your eye picks up all this little bits of damage and just kind of averages it across the radio. You don't really realize that what you're seeing is damage just on some trim. Anyway, I won't dwell on that any longer. The guy has painted the knobs too. I mean, that paint is coming right off them. Boy, oh boy. So, okay, string is in there. I mean, we can guess this radio is working. We can guess this. I mean, we wouldn't put a power cord on it if it wasn't working. I wouldn't think. On the back here, let's see, some hints. 12 SK7, 12 SQ7. They've listed 2 tubes there. Not exactly sure why. Goodness, thank goodness the antenna is here for this radio. On the loose side. Oh my gosh, my cat's here looking for me already. Okay, I gotta settle him down. Bear with me for a moment here for his daily cameo. Yes? Yeah, come on in. Come on. That's right, come on in. Coming? Oh my gosh, poor cat. It's winter, so they're stuck inside. Our 2 cats are stuck inside. And a little bit of cabin fever is setting in. I have the feeling he's going to be back at the door in a minute. Okay, back to the radio. There's the label here, and it contains the model number. And the model number is G2465. G2465. I've already got the schematic for it. It has these guys here, which were holding the original back on the radio. They're still here, but the back is gone. That's kind of strange, isn't it? An awful lot of these radios at this vintage are missing their backs. In many radios, the antenna is on the back. And if you get one of these radios, the back is gone and the antenna is gone, you're going to have a lot of trouble getting any kind of performance out of it. Well, I'm really tempted to plug it right in. Why don't we do that? And I have safe ways of doing this. And by that I mean if there should be a short circuit or something terrible inside this radio, all that's going to happen in my shop, I'll leave this on there, is some light bulbs are going to come on. Okay, instead of relying on my house electrical protection system, I've got circuit breakers in this house. I'm going to rely on these light bulbs. So when I apply power to the radio, the power is getting there through this light bulb, through it. This thing draws a lot of power, light bulb gets bright. This thing has a dead short in it, light bulb bright like normal. This thing working fine, the light will just be barely glowing. That's the theory. Switch on the radio is on. Power's not on here yet. The power switches are just up here. I've got two switches. I've got one main switch to kind of energize things. Turns this little light on, but nobody could ever see that. And then I've got a selector switch here. Down puts the power through the lights. Up means the radio is just like almost like it's plugged in the wall. But this is not plugged in the wall. This is plugged into a transformer that is plugged in the wall. So there's a transformer between the radio here. Anything on my bench that gets plugged into this guy. This is my bench power supply here. So that is through an isolation transformer. So this will be powered through an isolation transformer. Again, if it's the first time you've watched my videos, and just kind of give you a little bit of background of how I'm doing this. So I'm going to hit the switch. It's going to put power on the radio. This light should come on a little bright and then dull down, and then slowly brighten up as we hear the radio come on. Okay, I'll put the volume up about 25%. Goodness knows what's going to happen next. Okay, so a little bit of a glow. You probably didn't even see it in the camera. No smoke, no flames, no excitement here. The voltage reaching the radio is 100, can you see it? 118 volts. That's virtually full voltage. That means the radio is not drawing much power at all through that light bulb. There's almost no voltage drop on the light bulb. Here comes the radio. Now it's possible this radio is in perfect shape and there's nothing for me to do with it at all. It's possible. So I don't know which band we're on. This is a broadcast band at the top and shortwave band at the bottom. 6 megahertz up to 15 megahertz. We'll tune it, we'll probably figure out pretty quick what it is. So that's the AM band, I'm quite sure. So the low end of the AM band's here and the high end's on this side. So this is 55 kilohertz, 5500 kilohertz. 5500, yeah. So we should get stations right in this area. Some directionality in the antenna. So these antennas are directional, but what's most beneficial about them is the null on the antenna. So in one direction, like let's just assume out the back here it's strong, and off the edges it's weak. The strength part is kind of broad and rough. You can aim the radio back and forth. The null part is extremely sharp and deep and will knock out things. So that's the way to use these antennas. It's to knock out the crap you don't want to hear. So I'm knocking out the station we're listening to right now, but you wouldn't even know there's something there. And if I turn the radio 90 degrees, now the antenna is aimed perfectly at the station. This station's in Toronto. Toronto is that way. No. So this looks like 680. Very, very accurate on the dial here. I'll bring it a little bit in the dark. The reception quality is very typical of a decent radio in my shop here. Lots and lots of interference noises. That's 740. That's not easy to pick up. Let's see, 820, 840. So there's two stations here, 820 and 840. 840 is a French station. really a good test for a radio. So that's the French station there. So the radio's sensitivity is very, very good. Now as I tune through the station, just listen to the way it sounds. It has a very characteristic sound, a very distinct lower spot, like right there. So I get the impression that this radio's tuning is too sharp. The IF is too tight. That's why you hear that swoosh, swoosh, swoosh sound. And I don't know if that's really the case or not, but we're not likely to pick up any more stations here, but let's go see. Stations up there. Now, something I've noticed about this radio is the lovely paint job on it. It looked to me like somebody had spray painted it. That's kind of probably the best way to put paint on something like this, is to spray paint it. But when I look in here, I can see paint on the plastic all around the edges here, as if somebody took a paintbrush and tried to work paint into it. That's crazy if somebody did that. If they did this with a brush, amazing. It's amazing. But, okay, we'll try the shortwave band. To do the shortwave band, we need an antenna on it. The built-in antenna is not any good for listening to shortwave. So I'll get my antenna here. So this goes to an outdoor antenna. A long coax lead. Before I connect it, let's give it a go. Turn it up full. So that's a typical kind of hum you hear from a radio. That maybe the capacitors haven't been done in here. So no antenna other than, I guess, this little tiny piece of wire here. I'm not helping it much either. Okay, is it dead? Would seem that way without an extra antenna on it. You hear a darn thing there. Usually expect to hear something, so I'll put the antenna on. There we are. That just proves antennas, good things for radios. We're going to pick something up maybe in here. We might get some actual broadcast. Going faint. Oh.
Sorry about that. Having a sense of closure when you're old feelings all over again, can't they? So you know, where there's life, there's hope. Yes, I do. Well, acknowledging the great wrong he or she has committed, it can actually be very upsetting. And with the abuser's death, it goes, any last chance for a true, heartfelt reconciliation?
Yeah, yes, you're right. So, okay, let me rephrase perhaps.
Okay. When an abuser is that on some level, you're essentially bringing the abuser. Even if the abuser never.
So I'm listening to it to see if the ABC is doing its job.
Out abuse, still saying hurtful things and acting in hurtful ways.
Doesn't seem to be. It seems like it's getting too quiet.
It is a different matter. It creates
Volume is going up and down quite a range. When the radio, when the received signal is weak, the radio should be turning up its sensitivity, and we should hear a lot of hiss and noise come up. So as the signal weakens, the radio gets more sensitive. But what it sounds to me like when the signal weakens, the radio doesn't get really much more sensitive at all. The signal just disappears.
The honor still is abused. So what do you reckon the answer?
It could well be we're listening to a signal that is fading right out, and that's why it sounds the way it sounds.
Bring them honor.
We can't know with one radio what's going on here.
You don't have
But what we're really proving is that this radio works quite well, actually. We could potentially get some stuff up in here. Very, very fast tuning. Assuming the pointer and the dial are correct. And then we might get something right up at the end here, but pretty faded out right here. You just go right by those stations and never know they're there if you're tuning at a regular rate. You go by at the moment where the signal is a little weak, you won't even know it's there.
Question, because it's sort of a
One station on shortwave. I bet you there's more and I missed them. Good, okay, well, so that hum is of interest. You don't want to listen to that with the volume turned up. There's no other hum. I don't hear a power supply hum. Generally speaking, great shape. Now, the last radio I worked on started out in great shape and went downhill as I worked on it. But I did manage to resurrect it. Maybe this guy will do the same thing. So I'm going to cut the power. There's no power to it now. And let's take it out of its cabinet and see what's up. I don't want it. I think this paint is fragile here in all respects. Oh, come off easy. Yeah, right off. Perfect. Okay. Often radios are worn right in the area here from people with fingernails, not like me, turning the dials, and so you can sometimes tell the mileage on a radio just by looking around the knobs, and you can tell how much use the thing got over its lifetime. And this plastic, by the way, is almost certainly the original one, but it's bent in here. It's sucked in right in this area, right to the point where I believe it's rubbing against the pointer. So what would cause that? It's kind of in a little bit here, and a little bit here too. So plastic. Now, take this guy out. Let's just doubly be sure it can't have any power to it. W25. Okay, because it's appears to have a fragile appears to be a little bit fragile. I almost broke rule number 1. Do you see that? I almost grabbed the radio like this and lifted it up. This radio is fine, but a lot of radios, you're really tempted to lift them this way. Don't do that. Don't do that. And when you hear me say stuff like that, I'm really telling myself, I'm reminding myself. Okay, start on the lower screw. Let the radio hang from the upper one here. This is loose. So it's a pretty good drop here. We don't want that to happen, so I'm gonna tip them back down like this. I'm missing screws in here. Somebody's got them in their screw collection. Now the speaker is either mounted to the cabinet or to the chassis. Pretty sure it's on the chassis, so the speaker's coming too. So everybody come out. Speaker, antenna, the whole shooting match. I don't need this. That's a nice decoration there. Someday my wife's going to say, have you seen that nice little white cloth with the beautiful blue decorations on it? I'll say, oh, no. I have no idea of its whereabouts. Okay. Here we are. Let's take a look here at the top of this. So, I mean, obviously a really good thing to do is examine everything very carefully. And so there's not much to see here. The dust is fairly heavy in the middle, but it's been removed around the edges, so it's had a light cleaning, we could say. Two-part capacitor. Capacitors here. Originals, not of the sort that people tend to change. Anyway. So metal tubes, rectifier, and output tube. Okay, let's flip it right over. We can flip this right over on top of itself. Oh! Surprise! Oh, look, I didn't attach this with screws. Ooh, 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 ooh. Okay, so that's, what was that? Something just fell out of this radio. What just fell out? That little thing. Okay, let's put it back like this. Broadcast and shortwave, thank you for marking that. This is not a good idea to have this on here and not screwed in tight, not made so you have a really good metal contact or electrical metal contact between this plate and the rest of the chassis. Not good to have it loose like that. Oh, it's full of old timers. I'm stunned. The radio's working great. Oh, look at that thing. Oh my gosh, isn't that a stunner? I'm stunned. I really was not expecting that. See, I'm all happy now because look at all the stuff I get to do. Oh my gosh, it's got its original filter capacitor in it. Oh, this guy's completely original. Wow. It really is. It really looks. But that plate, well, somebody had to change this cord. Look what they did here. They put a strain relief on it, but they put it on the wrong side. There's no strain relief here. Interestingly enough, because they've splayed the wire out, just doing that kind of adds a little bit of, not much. This is pulled tight here, not much. Okay, so having the knot on the wrong side says something about the person who did this. Having this done and nothing done inside says something about the person who did this. Well, they didn't do anything. And I think lots of people can manage to put a cord on. So he's put on a polarized cord. You know, most of these cords now are polarized. Of course, you have to get an old one that's not polarized. This can give a false impression to people about what's going on with this radio. This is a potentially, I say, dangerous radio. Until I study the schematic a little more, I think one side of this line cord is attached right to the chassis, direct. I'm not sure though. I suspect it is. This nice piece of braid they used back here. Kind of wonder, wouldn't you? So this is the phono input. The phono input. The phono itself is insulated away from the chassis here, and then they take a shielded, not shielded wire, braid, and attach it to the chassis over here. Why not right here? There's a good reason for it, I'm sure. See, there's another wire coming up and attaching right here. And this looks like this has been fooled with. This doesn't look like factory quality solder here. I don't know why that would be there like that. Is that right? And that's something to check out again on the schematic. see how it's done. So this is probably the oscillator coil here. Here's some adjustments here on the end of the radio. You can't align this radio unless it's out of the cabinet. At least you can't do some of the alignment steps. Antenna wire coming in. Very unusual how they've done this. It comes in through a hole, just goes through this piece of non-conductive material here, just loop through a hole and back out. As if this is their strain relief technique. But wow, that's kind of extraordinary how it's just kind of weird how that's done. And then off it goes top side. Well, this explains why when we turn the volume up, you hear that particular kind of, I'm going to call it a high impedance hum. That's what I would call that. Wow, there's a fair bit of number of capacitors in here. 1, 2, 3, 4, 5, 6, 7, 8. 8 potentially bad actors. And yet the radio works pretty darn good. So my thinking here is, as usual, I've sort of picked up potentially two problems here. One is that hum. The other one is maybe a little bit of a lack of sensitivity or a lack of AVC operation on shortwave. I'm looking right here, and there's a tiny little strand of wire hanging out there. It's not of any importance in itself, except again it says something. I think in a factory environment that would not be tolerated. That little piece of wire there is doing nothing, but the same sort of thing somewhere else would be a short circuit. And in a manufacturing environment, you can't tolerate letting any of this appear anywhere in what you're building, or you're going to start having a significant failure rate at the end of the production line. So that suggests to me somebody else did this afterwards. This is an after the fact thing. True? I don't know. Maybe this was in a factory that had very bad inspection. I don't know. So what to do here? You know, it has a phono input. We'll try to isolate the hum. I think the first thing, that high impedance hum. Try and figure out where that's coming from. And you know, I could take a guess right off the bat from experience and say it's the capacitor right off the volume control. Can we spot something like that? So that's a volume control. I can't believe this doesn't hum. Oh my gosh. Pyramid. Hey, if you're going to go buy capacitors, buy a pyramid capacitor. That looks like a good one. Or this could have been replaced. It's possible. It doesn't look like it. So I'm looking for the center terminal of the volume control here. Oh boy, it's really buried from sight because of this capacitor, which I doubt I can move. Real problem is I don't have enough light on it here. So this might be a little hard on the camera. So there is a wire attached to it. Oh my gosh. There's a capacitor down under there. Oh man. There's a capacitor right down here. It's tied with a very short lead to the center terminal of the volume control, and then it's on its way I think it's coming to this tube terminal right here. It just fits right in, out of sight down there. Son of a gun. So the bracket that's holding this big guy in the way here is soldered to the chassis. I don't like fooling around with these big blobs of solder. Take that and lift it out of there. This guy's potentially on his way to being replaced, even though we didn't hear any hum. Didn't hear any hum. You know, when I think about it now, when I looked at the schematic, it shows that the speaker is actually a field coil speaker. Well, this is not a field coil speaker. That's a permanent magnet speaker. There's the output transformer sitting up on top. Maybe I looked. Oh, you know what? I was mistaken. You ever do this? You have a series of wrong thoughts, but then the last one is correct. But then when you think through it again, you go down the same track of wrong thoughts. Yes, that's me. So if we want to make that the first capacitor, it's just about the toughest one in there to get at. Oh my gosh. Can I just lay one over top? Even that's tough in here. This guy is just, he's messing everything up. Oh, and if I pull him out, I can loosen this bracket enough to slide it. Not likely. Not likely. I don't think you can loosen this at all. So loosen the volume control, move the volume control for a bit. No, that's not going to help. That's a bad move. What else is in there that I might have to poke around with if I get this thing kind of opened up in here? Yeah, I think I'm going to have to desolder this. If I'm going to replace this, I would want to take it off anyway. I got to get a big honking soldering iron to do that. So this is all in the assumption that the hummy sound we heard was coming from that capacitor. And another option here is to say take this one out. Look at this thing. It's like somebody's been in there hacking at it. And why is this like this? Look at that down there. Well, this almost looks like it came from somewhere else. So with the radio flipped upside down, this is the bottom, and that's the top. Is there some chance that this thing gets hot and melted its wax downward? Doesn't look like that, does it? It looks like somebody took something, went whoop, whoop, whoop. Almost looks like somebody tried to smooth some wax over top of it. Could somebody have done that? So that's another one that it's just ugly enough that it's asking me to take it out. This one looks really nice, fairly nice. These ones, they don't look so nice. They look different. It's funny how these things can be in the same place for all these years. Open it up and they look so different. One that looks clean. These ones look a little, I don't know, like somebody dragged them through the dirt. This one looks like, I don't know, somebody tried to plaster it. But it all adds up to nothing in particular, doesn't it? Okay, so choices. We operate the radio and try to convince ourselves that the hummy sound is coming. Oh, yeah, let's just check one more thing. Aha, he says. So these guys on the back, these phono plugs, are often switches built into them. And as you push, you have a phono plug with a funny long prong on it. It looks stupid, in fact. You plug it in, the long prong comes way back here and separates two contacts. And in doing that, it breaks the connection coming out of the radio part of this, coming out of the detector. It breaks it and stops it, and from there, whatever's coming in on the thing you plugged in, then carries on through the radio, through the amplifier. This is a shielded piece of wire. This is the piece coming out of the shielding. So this is like the center conductor here. I misinterpreted this entirely before. There's no switch here. This is always hooked up. So in this case, what they're hoping will happen, as I understand it, is when you plug in your record player here, you lower the impedance of the circuit enough that the radio signal is weakened and can't be heard anymore, coupled with the fact that you tune the radio between stations so you don't have the radio signal getting here in the first place, the radio program signal. Isn't that a crazy arrangement? So these can go either way. They can either have a switch in them or do what this one's doing. This is important to figure this out because I may use this as a test point. Actually, if you tried to push one of those long ones in, kind of a long thing, it would bang into this wire, I'm pretty sure. And back in the day, typically you would have these long ones. I don't have one handy to show you, but the prong sticks way out. It looks strange compared to the standard phono plugs. Okay, anything else here we got to extract from this guy? Not really. I think that's kind of the starting point. What is the starting point? If this was a switch, you know, I would push a plug in there, interrupt it, turn the radio part off, and then listen to what's left in the radio. I'm sure we would still hear that hum. I could take my signal tracer and we can poke around and see where the hum occurs, but I'm not that familiar yet with the circuit layout in here. It'll take a while to sort that out. Just go directly after the capacitor, change it, and then afterwards play the radio and see if the hum is still there, and use that as our approach. I think I'm on my way to changing that capacitor anyway, no matter what. So I'm going to get myself a soldering iron. I'm going to loosen this off, unless I want to cut it. It's attractive to cut it, you know, because boom, it's done. Let's cut it. Let's cut it, and then boom, it's done. Where's my cutters? Oh, crap, there. Okay, so my cutters have wandered off. My heavy ones wandered off in the house. I got to go find them. Okay, got my heavier cutters here. And we just can't cut through this. Yep, wasn't too hard at all. There we go. Okay, he's out of the way. Three-parter. There he is. Looking really nice. Really tucked in there. This must have been one of the earliest parts they put in this radio. So we're going to nip this one out of here and we're going to test them. Now the reason I'm suspicious about this is because another radio I just did had exactly the same hum, and this capacitor, surprising to me, was the cause of it. This is the capacitor that blocks the DC that's been developed in the detector, the DC that's going to go for ABC voltage. This guy blocks that from carrying on to the grid of the first audio amplifier. This capacitor is stuck down here. It's not that tight. There it goes. Glued itself. So I can already see the edge of the paper roll versus the wax plug on the end there. I can see that's often a sign. This one's a little bit better, but that's often a sign that there's the hermetic seal they're trying to make on these capacitors with wax has failed. Now where's this other end going exactly? It's going to this terminal here. Well, this capacitor just doesn't want to be out of the way. It's going, so I'm going to nip it here, leave a bit of wire so I can find where I was. Oh, I'm using this great big cutter still. Get this guy out of here. Here he comes. This should be a small one, like a 0.003. Doesn't look that bad. That's where it was laying on the bottom. Okay, let's give him a test here. So the test I'm going to do involves applying a controlled DC voltage and then measuring, in quotes, the amount of electricity that leaks through the capacitor. A good capacitor, the amount is basically zero. So I can't give you a current or anything like that. So this instrument is sensitive enough, it uses a magic eye, and all I got to do is watch what happens to this gap at the bottom here. while we do the test. Any current flowing through the capacitor will tend to close the eye. So of course when I first hit it with the voltage, there's a rush of current into the capacitor, the eye will likely close and then come open. I watch the speed it comes open and how far. See how big the gap is right now? 50 volts, here we go, right open. So it opened fairly slowly too, it didn't snap open. That tells me this capacitor is in great shape. That's what this is telling me. So we're going to try it at 150 volts. Now it's not opening all the way now. It's opened about halfway. And if I put it up to 250 volts, I bet you it just won't open. No, it won't open anymore. A good capacitor will open at top voltage, almost 500 volts. If I put a brand new capacitor in here, that eye will pop open. Think I'm lying? Am I a liar? This is a brand new capacitor. Starting at 250 volts. Pop. It takes a moment to charge, then it opens wide. 450 volts. Open wide. Don't touch that. Now this device has a safety feature. As soon as you let go of this control, it's spring loaded, it snaps back into this position. A short circuit is applied between these two terminals, so this guy gets drained fairly quickly, so you don't have 500 volt capacitors laying around on your bench. So, a little bit bad. Certainly in a lot of radios, they're way worse than this one tested. This is not perfect. It's in a sensitive spot. So, although I really can't explain why that particular hummy sound would come from this situation, that certainly was the case with one of my recent previous radios. And I was a little bit surprised. So now we'll put another one in there, a 0.003. Okay, I'll get it installed and then we'll test the radio. Okay, we'll just solder it in here. Wow, look out. Okay, the other end. Oh, something's happened to the other end here. I've just noticed that there's paint all over the speaker on this radio, and there's holes in it. Oh my gosh, let's take a look at that next. I missed that. Paint. How do you get paint? Well, it's not paint, it's probably a repair of some sort. Can't look right now, I'm too busy. Too busy melting metal. Okay. Yeah, it's got it. Okay, so first capacitor replaced, and speaker. What's going on with that speaker? It's a huge repair here. There's a crack in it here is this? What is this? Oh, that's from painting the paint. Oh my God, they painted the radio with the chassis inside. Yeah. Oh my gosh. What are these little things here? Screws driven through this metal plate into the speaker. Just making observations here about how things are done. So this is a spill. This is a repair. And this is a miss. Okay, that's good to know. Let me put this upside down again, because we're going to play the radio. And we're going to listen to see if that hum disappeared. Okay, volume's here now. Switch is off. Off. Switch is off. Solder out of here. Switch on. Just notice on the inside of this metal cover plate is a protective piece of cardboard. Exciting stuff, eh? Okay. Ready. Are we ready? We are ready. Switch was off. Okay, I'm going to switch it on, but there's no power. And now I'm going to apply the power, which I've done. The power is applied. You can see the voltage here on. That's the voltage right at the outlet. 16. The radio light doesn't work. Oh, it does work. Works when it wants to. Doesn't work well when it's not screwed in tight. It's better to have these in than out. Okay, I can't really get in there. There it goes. There we are. Okay. Lights in. Hey, it's another repair. Okay, turn this radio up. What does it sound like? It's got that same sound. What would be next? I think it might be interesting to study how, on the schematic, how the chassis is involved with this radio, and see if there isn't a single connection to the chassis from a capacitor. I'm busily looking for it in here. Let me turn it down a bit before we have some excitement. So that didn't work this time. Changing that capacitor did not work. So we're listening to what is coming on the slider of the volume control. Look at that. Look at that. That's how sensitive that guy is. Push it closer to the chassis. Getting closer to the screwdriver made a difference. Well, that's where the hum's coming from. It's coming from there and the circuit related to that capacitor. So maybe there's a little more to it. If we look on the schematic, there'll be a hint. And the other this is why I'm suspicious that there's something about the connection to the chassis. That little click. These are things I notice all the time. I never ever comment on them in any videos, but all my life I've noticed this. When I touch the chassis, you'll hear a click and then a hum. Almost like you can hear me tapping it. So the click part is a balancing of the charge between the chassis and me. There's a sudden charge shift, and that's the click. Let me charge myself up here a little bit. Now, this is crazy. I can't believe this will make a difference. Oh yeah. So I charge myself up here. You can hear me rubbing my feet on the rub. There you are. Science at every turn. Now, oh yeah, so the last point of that, the hum increasing, suggests to me that what we're hearing coming out of the speaker is the hum in the chassis making it into that capacitor or that circuit somehow. And the chassis hum should be drained out properly to the B minus or something like that. Something like that should be going on, maybe it's not. So we're hearing the chassis. That's my theory. Okay, let's take a look at the schematic and just see how this radio is handled grounding wise and stuff like that. Okay, so here's the schematic for the radio. Got this from Pacific TV. I think that's on the west coast of Canada. A lot of Canadian schematics are available at Pacific TV. Thank you very much, Pacific TV, for having acquired all these. Now this one's redrawn. This is not the original schematic by any means. Somebody's taken a lot of time to redraw this, spaced it all out so it's nicely balanced on the page. Great. What we want to really get right down to is this kind of thing here. So here's a connection to the chassis. Here's one here. What is it? It's to the shield of the tube. So this is a metal shielded tube. That's the metal shield connection. And look, it's extended over to this other tube on its shield connection also. And we're almost certain to find one on the first tube also somewhere. Shield right to the chassis. Now, if we look at the antenna, we should see some chassis stuff too. Let's put that bar up there. Come on down. There. So yeah. So here's this is the wire hanging out the back of the radio. It's protected with this very small capacitor. The person holding the wire is protected by this capacitor. That's my understanding of it. Because the other end, the other side, through this coil, through this wire, into the chassis, is connected back through this connection, indirectly, just through a capacitor, back to here. So, you know, if this capacitor is no longer capacitating properly, if it's lost its gumption, maybe it's not drawing down all the radio signals that are building up in the chassis here, down here, and bonding them, if you like, bonding the chassis to the B minus of the radio. So this would be a capacitor worth finding if maybe this is the guy who causes the hum that we hear, because it's failing to quiet the chassis. Let's try this one, see if we can find this guy. So it looks like it's soldered right to the chassis somewhere. I should be able to find it in the radio. And what's this mean? What does that mean? Chassis, ground. I have no idea what this means, but yeah, I don't know what this means. The chassis is not solidly grounded or tied back. It's tied through a capacitor. What's this? Yikes! I don't know what that is. Okay, it's probably not the only thing I don't get. That's good enough for now. Let's just find this capacitor, 0.025. You know, there's another important one in here too. This one here, this 0.02. This 0.02 is in effect right across the power line. So if this guy were to short out, Niagara Falls would try to pour electricity through it. And of course my house circuit breaker would stop that as soon as it started. It would stop it. Or would it? What if this fails and doesn't draw enough current to trip my breaker? Maybe 10 amps. 10 amps go through here. That's a lot. That's a lot of current. But it's nothing to my circuit breaker. 10 amps is regular stuff. Fire ensues. That's why this capacitor is a little critical. I have special capacitors to go into this position that won't catch fire. And this guy, okay, so we'll find these two. We'll find these two capacitors. Oh my gosh. This one should be fairly easy. This guy, well, he's on the chassis. Gotta be findable. Gotta be. Radio's on, so I'm going to switch it off now before I forget and get hurt. So just look at all these capacitors and try to spot one that is soldered right to the chassis. It may not be like that. It may be anywhere in here. Oh my gosh. Quite a few of them soldered to a spot here. This is probably a B- point in there. See, this one's coming up to these. It's not to the chassis though. Okay, big blobs of solder on the chassis. There's one down here, but there's no wire in it. What would they be soldering there? You know, that's holding a coil form. You can't really see it, but there's a coil there, and the solder is just on the holding part of the coil form. Somebody's going to ground here somewhere. You know, that's clearly soldered to the chassis, but what of it? It doesn't go anywhere. It just goes over here. Somebody in here's got it. Somebody, somewhere. Now, sometimes there are extra terminals on tube sockets. Believe it or not, I've come across somewhere they actually have extra terminals, like off this rivet. There'd be an extra terminal hanging out here, and that can be a connection to the chassis, but not here. Not that I've seen so far. The rivets here, these are just rivets holding the tube sockets. I can't find anywhere. Would it be up on top? It's a. How big was that capacitor? Let me just peek again. So it was 0.05, wasn't it? Isn't it 0.025? 0.025 is a fairly small one, but it would still be, I'm pretty sure, one of these guys. Okay, well, another approach then, if it's one of those guys, just go through them. So this guy's connected to a tube. Where's the other end of them? The other end. Wow. I can't imagine it goes to the chassis. There's nowhere down there. Nope. And nope. Must just be hidden under something. I don't think that can do it. So here's a terminal strip up here. The terminal strip, you know what? This terminal strip, I think this is grounded to the chassis here. I think this terminal strip is grounded. It's got two wires on it. Two wires on it. Often when they're making these connections, the designers like to do the kind of like the star thing, where if you're going to make a connection to the chassis, then everything's going to go to that one spot. That kind of thing. Any other chassis connections would go to the same spot. So the objective here is just to simply take a resistance test between the chassis and this. Sure enough, there we are. So there's the ground. There's the chassis terminal. So hard to spot. And there's a rivet onto the chassis. Now normally in a good radio they would solder that rivet to the chassis. Or they have a wire leaving this and going right to the chassis somewhere. And you know, I see one, two, no, there's tons of capacitors on here. Three. Not this one. Not this lower one, but this guy. There's three of them hooked up to that. Yeah, definitely this guy. Definitely this one. Yeah, it looks like two wires reach the terminal, so it's these two capacitors. Well, it could be the two I'm after, actually. This could be it. I'm trying to see the size on them here. So it's nice when people install capacitors with the size showing up, and I certainly don't take the time to do that, so I can't complain too much. You rotate a capacitor on its leads, you're gambling. But I think we're on our way to changing these anyway. Come on. Just let me get a little peek of it. Maybe on the other side. 0.02. So this is a 0.02. And the other one is this ugly son of a gun here. How do you like that? We're back to looking at this one. 400 volts. Okay, so pretty sure we're gonna be changing this anyway. There it is, 0.0. Oh, looks like either 5 or 2. There's a big blob of wax on it here. Yeah, that didn't work very well. Then you can scrape off the wax and see the numbers underneath. 0.05. 0.05. And the other one was a 0.02. 0.02 and a 0.05. Okay, let's double check the schematic here. 0.02, 0.05. So there's a 0.02. Maybe it's a 0.025 and I just didn't see the last digit. And the other one, the capacitor rate to the chassis. Oh, well, what? There is another one in here? There it is. Yeah, the one that goes to the shield. So this could be a hum causer too. Again, if we're not draining out the signals that are building up in these pieces of metal, like you can think of the metal can around this tube as just a piece of metal floating above this radio, if this connection wasn't there, connected to nothing. And then that piece of metal is going to act as an antenna. In fact, it's a high impedance antenna, it's not connected to anything, it's going to actually receive pretty well. No one's going to know, of course, because it's not connected to a radio. But it is, because it's sitting outside this tube, and whatever's going on in this piece of metal can affect things going on in the tube. Now we're going to hear it come out the speaker. So you've got to quiet the piece of metal, including the chassis, which is just a really big piece of metal close to the radio. Quiet them all by tying them back, ultimately back to the negative return. Right. So we'll change those two capacitors and check again and see if the hum is gone. Should I do them one at a time? There's 3 of them. I didn't find this one yet. We'll leave this one out of the picture. These are the ones I'm interested in for the hum effect we're hearing. We'll do them one at a time. Let's do the one that brings the chassis back to B minus. Let's do this one. 0.025. Okay. Okay, 0.025, which is 0.02. Which was 0.02. Wasn't it this one? Which one was it? 0.05. So it's this other one. It's this guy. 0.02. There's another number there. 0.02 something. Okay, so this is probably the 0.025. Let's get them out. Get them out of there. .02. There's a 5 under there. 0.025. Okay, let's check them out. Over here. 50 volts. There we go. Can't even open on 50 volts. So we know it's leaky, so to a larger degree than you would want, this is a resistor now. You know something else? Yeah, I won't bother with that. I was going to say, you know what else? It's probably turned into a bit of a battery. I won't fiddle with that. So 0.025. 0.025. Here we are. 0.025. So I'm going to fit that in, and we're going to play the radio. I disconnected this one. Looks like we're going to do two at once. I won't know which one of them is really responsible. So I stick this one back. I could clip lead this back temporarily. Okay, I'll install this capacitor here. Okay, so I've got this one soldered in. This one that I cut free, I have stuck it in there. It's making contact again, so it's back in the circuit, but I can pop it out. This is the one that's quieting the tube shields. So it'd be pretty interesting if this were not there, what would happen. But for now, we're basically testing the change of this capacitor. This looks like a crack in this one, but I don't know what it is. It's not a crack. You can't crack that stuff. Okay, so we're ready to power on. My hand on the volume control. Here, oops, volume control. There we are. Okay, so it's turned right down. This is fine, hanging out like that. We're good to go. We're going. Did I turn it on? Yep. The light didn't come on. Oh, I know why it didn't come on. I didn't plug it in. Okay, back off. Power off. Plug it in. Oh, I whacked my microphone there. Here we go. Yeah, this time the light's on. Here it comes. Oh, well, there's that same hum. We've not got it yet. And now I'm going to turn the volume down, pop this capacitor off. Or listen. So now I hear a squeal. Some kind of oscillation has developed without this capacitor. Oh. Okay. And, we lifted it from the grounded end, the chassis end. So this is now an antenna hanging here. It's exactly the kind of thing we're trying to get rid of. You can hear that kind of hum that I was after. Change this one, it's going to go away. Okay, enough of that. Let's change that one. Change this guy out. See what happens. I'm going to cut him out and test him. Let's do that first. Bring him out. Okay, buddy, you're going into, I'm sorry, I was going to say you're going into retirement, but this situation's worse than that, Mr. Capacitor. Your job is done. You're kind of heading for kind of a Soylent Green type future here, Mr. Capacitor. Sort of a Soylent Green. Not really. He's heading for the landfill. That's probably where he's heading. Okay, this is the ugliest guy in the radio. Appears to be involved with the hum. Looks like it overheated. It just looks like Something horrid has happened inside this capacitor. 50 volts. Opened up perfectly. 150 volts. Okay, not opening really at all. You can't even see it on the video, but it's opened a crack. So she's leaky. A little worse than the other ones. As far as capacitors go, that's really not the worst one in the world I've ever seen. But I've seen a lot of bad capacitors in my day. Still is my day, by the way. Okay, so we'll put a new one in there, and then we'll test the radio for that hum. Okay, I'll make this solder the last connection here. There we go. Okay, so that's the other potential hummer capacitor. So I'm theorizing. Ready to test the radio again. Ready, and where's the volume? Volume down. Power on. The light has come on. Dim bulb's normal. Voltage 115, going up a bit. A little bit of volume. Will the hum still be there? And the answer, it looks like the answer is yes. Now, one thing we got to bear in mind here is I got the volume up quite high to get to that. At this point, if the radio is tuned to a station and the radio is working, the speaker is blasting away. You never hear this hum. You never hear it. See, typical volume setting would be something like that, I'm guessing. No hum. So one thing we didn't do, we didn't make a quantitative assessment of the hum. But qualitatively, I would say it's the same as it was. I would say I didn't change anything there in terms of that. So what did we learn? With the capacitor missing for the tube shields, an oscillation was occurring, the effects of which we could hear in the speaker. You can have lots of oscillations in these radios, and there's really no effect in the speaker other than the performance might be off, and it's not obvious why. And I'm pretty sure at times you can get oscillations, neither of which you could hear, but in combination they're producing products, difference products, and you can hear that stuff. That's where you would get, like my last radio for a while had a very slow wow in it like this. And I think it's really from the slight difference between two frequencies. I don't know what or where or how, but there was this slow thing, and that's what I thought it was. Probably two very close frequencies somewhere else in the spectrum. Now what? Now what? So this radio doesn't have any hum in the power supply from this capacitor, so I'm really not inclined to change it. Maybe before changing more capacitors, we can do a little bit of alignment work with it and just see where that is. My guess is it's beautifully aligned, but we will see. And then after that, we can make some judgments about changing out some more of these old capacitors here and look for performance changes while we're doing it. That's kind of my modus operandi. But for now, I think that's it for today. Not so bad yet. Pretty good, actually. Pretty good. Got 3 dead dogs out of there. Oh, okay, they weren't dead. 3 sick dogs. Weak dogs. Leaky dogs. Okay, I'll see you on the next video. Thanks a lot for watching.